Calculating concentration from acid-base titration is one of the most common questions in GCSE exam. The technique is always the same, it's just you need to look at the number you are dealing with. In this question, they give you an equation for acid-base titration between sodium carbonate and nitric acid, and they will always give you the concentration and volume of one of the two titrants, and they will ask you to calculate the concentration of the other one. So here in this case, they give you the volume and the concentration of sodium carbonate, and they give you the volume of nitric acid, and they ask you to calculate the concentration of nitric acid. You need to pay attention to two things. First one, that they ask you to give your answer to 3 significant figures, so that's quite important. The second thing is that you need to notice the balanced equation. So in this equation, you notice that there is 1 mole of sodium carbonate react with 2 moles of nitric acid, which means whatever the number of moles we find for the sodium carbonate, nitric acid will have to be double that number of moles. To answer this question, first of all, you need to calculate the number of moles of sodium carbonate. So moles of sodium carbonate equals the concentration times the volume in decimeter cube. They give you the volume in centimeter cube, so you have to change that into decimeter cube by dividing by 1,000. So concentration is 0.124 mole per decimeter cube times this concentration in decimeter cube, which is 0.025, and the concentration and the number of moles are 0.0031 moles. Now we said that the moles of nitric acid will be double the moles of sodium carbonate, so the moles of nitric acid will equal 2. This value we found for the sodium carbonate, so 2 times 0.0031, so equals 0.0062 moles. The final step is to find the concentration of nitric acid, and the concentration equals moles over the volume in a decimeter cube. The volume of nitric acid they gave you was in centimeter cube. Again, we have to change this into decimeter cube, which equals 0.0236. So the concentration here will equal the moles we found for the nitric acid, 0.0062, divided by the volume in decimeter cube, which is 0.0236, and your answer will be 0.026271. And to find the concentration in 3 significant figures, then it's 0.263 mole per decimeter cubed.